Okay, welcome to your 1.7 video lesson for linear models and scatter plots. If you notice, there's a couple things that you're going to point out. There's stuff already written on the notes. That's because I'm just going to kind of go through and read what the definitions are. If you want to take a second to pause the video to copy them down before you start watching, that's fine. And you'll also notice that there's this little graphing calculator on the side of the screen. I have a graphing calculator emulator that shows you what I'm doing on my graphing calculator so I can show you how to do this properly. So in Algebra 2, hopefully you remembered a little bit, at least talking about being able to take a bunch of points or a bunch of sets of data and try to see if they have a linear relationship. So a regression is a mathematical model of the relationship between the independent and dependent variables, or x and y. A scatter plot is a graph of those data points used to model the relationship. And when we talk about that relationship, we're talking about a correlation. We're trying to see if there is a relationship between the independent and dependent variables. When something has a strong linear relationship, we're going to use that line of best fit as a representation or mathematical model of the data. We're also going to use it to predict different values and see if it's actually realistic. So remember that a positive correlation looks like a set of points that's going up in a positive slope. A negative correlation looks like a set of points going down in a negative slope. And when something has relatively no correlation, it just looks like a set of points being graphed everywhere. When we talk about that line of best fit, we have to start by choosing 2 points and sketching a line. We have to try to figure out if our line is close to most of the data. It's not going to be close to all of the data because there might be some outliers, but at least that it's close to all of the data. If you decide yes, that your line is close to the data, then we're going to use those points that you picked to find a slope and create an equation of a line. So let's look at example 1. Akron, Ohio and Wellington, New Zealand are about the same distance from the equator. Make a scatter plot for the temperature of the data and identify the correlation and sketch the line of best fit and find its equation. So lots of things listed there. You'll notice that it gave me a table and that I already set up my graph. So kind of to walk you through my process, I started by drawing my axes. I noticed that the lowest temperature for Akron, Ohio was 33 degrees, right here. And I noticed the highest temperature was 82, right there. So I had to spread out my x-axis from 33 to 82 as best as I could. So I counted by 4s. I did the same thing for the y-axis with the Wellington, New Zealand temperature. However, the lowest was 51 and the highest was 67, so I counted by 2s instead of 4s because temperatures were closer together. So now I'm going to take a second and plot the points on my scatter plot. This might be the annoying part of the video because I will be listing a bunch of numbers. So if you want to plot the scatter plot on your own and then fast forward through this part of the video, I would recommend it unless you want to watch me plot all these points. So my first point on the table is 3367. I then have 3767, so somewhere right there. 4865, somewhere right there. 5961, somewhere right there. 70, 56, which is somewhere right there-ish. 78, 53, 78, 53, somewhere right there. 82, 51, 82, 51, somewhere right there. 80, 52, somewhere right there. 73, 55, 73, 55, somewhere right there. 61, 57, 61, 57, 49, 60, 49, 60, and 38, 64, 38, 64. So your graph might look a little different than mine. We're human. There's human error when we're graphing points like this. The next thing I'm going to do is I'm going to identify a correlation. Well, as the Akron, Ohio temperature goes up, the Wellington temperature goes down, so it looks like a negative correlation. L-A-T-I-O-N. And then it wants me to sketch a line of best fit. So I'm actually going to pick the 2 points that are the kind of the ends, this 3367 and the 82 point. And it looks like my line is at least close to all of the data. So again, I picked 3367. And 8251 as my points. And now I'm going to use those points to find a slope. So as usual, y2 minus y1 over x2 minus x1, which is 51 minus 67 over 82 minus 33. This is negative 16 over 49, which thankfully I got my handy dandy on-screen graphing calculator to do that. Negative 16 divided by 49 is about negative 0.3, we'll do to the thousandths, 0.327. We're then going to use that slope that it gave us to create an equation. So I'm going to pick the point 3367 just because the numbers are smaller, but it should work with 8251 as well. We're going to use point slope form, so y minus y1 equals the slope times x minus x1 to model this data. We do y minus 67 is equal to negative 0.327 times x minus 33. The only thing I need a calculator for in this so far is to do negative 0.3727 times 33. So I'm just going to go times 33 to do, it ends up getting plus, because it's both negatives, 10.77, is it 6? 776, yep. And finally, I'm going to add 67 to both sides to get y by itself. And get y is equal to negative 0.327 x plus 77.776. And this is the equation of the line of best fit I picked. Now, sometimes we'll use that equation to predict future data, but for right now we were just practicing deciding what correlation we graphed, making a scatter plot, finding the slope based on 2 points, and then turning that into an equation. So now we're going to talk about the correlation coefficient. And this is what we need the graphing calculator to help us with. And the correlation coefficient is the measure of the strength of the relationship. Strength of the relationship. Okay, so I'd like to take a moment to apologize. I had to turn the fan on. It is warm in here, so the video might sound a little breezy. I am sorry if it's an issue. So again, we were talking about that the correlation coefficient measures the strength of the relationship. And we use the variable r to talk about the correlation coefficient. And it's always a value for a line between -1 and 1. So if r is 1, then this is the strongest positive correlation. Positive correlation. Which actually means the strongest positive correlation is a positive sloped line. Like it's actually a line. If you have a correlation coefficient of 0, there's no relationship or no correlation. And if you have a correlation coefficient of -1, it is the strongest negative correlation, or a negative sloped line. Negative correlation. Or a negative sloped line. So again, you can use your graphing calculator to perform a linear regression, which helps you find that mathematical model or the line equation that we're going to use. So let's look at example 2. And we're going to do a lot more on our calculator this time. So anthropologists use known relationships between height and the length of a woman's humerus bone, the bone between the elbow and the shoulder, to estimate the woman's height. Some samples are shown at the table. So as you notice, again, I already set up my axes. I noticed that the lowest was 25 for humerus length and the highest was 39. So I happened to be able to count by ones and fit that. I noticed that the lowest height was 140 and the highest height was 180. So I was able to spread that out. I think I counted by 4s. So now I'm going to take a second to plot that data. Again, this is the annoying part of the video because I'm just going to read off points and plot them. If this is annoying to you, you can pause it, plot it yourself, and then like fast forward through this. So I'm going to start with 35, 167, right there, 27 for 146, so somewhere right there, 30, 154, somewhere right there, 33, 165, 31, 2, 3, 165, 25, 140, 39, 180, 149, or 27, 159, 27, 149, and 33, or 31, 155, 31, and 55, right there. Okay. So just by looking at it, I know I'm going to have something that's a positive correlation, but you got to use your calculator to find all of those points. So I'm actually going to flip over to the graphing calculator and walk you through how to plug in points, how to do a linear regression so that you can see. Please note that there's this big space for you to write it down right here. I am not going to write it down because I'm going to be walking you through it. This is where I'll write the line and the correlation coefficient when I actually get them. But if you need to remember the calculator instructions, you need to write them down yourself. So I'm going to come to my calculator. Let's clear it out. And the first thing I have to check is I have to check that if it's in the right mode. So I hit second. I think that there's actually, give me a moment. Oh, cool. So I can actually show you the key history, except for I don't want it that big. No one cares that much. You go second 0, which is catalog. And now we're going to scroll until we see diagnostic on. La 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 la. Diagnostic on. And then we're going to turn it on. Okay, done. The next thing we're going to do is we're going to enter all of that data into a list. We're going to enter all of that data into a list. Whoa, I went down 58 times. So we're going to go stat edit. Oh, would you look at that? My data happens to already be in here, but then you just plug in things like 35, 27, 30, 33, 25, 39, 27, 31, down the x values, and then L2 will just be the heights, where we used L2 for the heights. Okay, quit out of that. So you might want to pause the video while you enter it into that area. Again, that's second. Oh no, not second. No. No. Now I'm messing up the keylog. Annoying. But whatever. Delete. And remember that's stat, edit. Now I'm actually going to go to calculate. And I'm going to go down to linear regulation. Notice that we didn't talk about quadratic regulation or cubic regulation or quartic regulation this year, or not last year. This year we are going to hit them. So I'm going to hit linear reg. The x's, my x values are in L1, and my y values are in L2. I don't actually know what this means, so I'm going to leave it. Go down, go down, go down, hit calculate. Boom! Would you look at that? I had some linear regulation. So it looks like my correlation coefficient are, whoa. And I'm just writing this down before I exit off the graphing calculator because I'm not going to be able to see it, is 0.991. Okay, so a very strong linear correlation. It's not a perfect one, but it's super strong. And the line that it gave me is that we can use to mathematically model this data is y equals 2.754 x. I'm always rounding to the thousands place. We're going to do the thousands place a lot in this class. Plus b, which is 71.974, to look something like this. So again, if you need to look over those key logs, you can pause the video and look them over for right now. Otherwise, we're going to move on. So the next part says a humerus of 32 centimeters was found, and we're going to predict the woman's height. Well, humerus was x, so I can plug that into my equation that my linear regulation function got me to get 2.754 times 32 plus 71.974. And use my handy dandy on-screen graphing calculator. Okay, I don't need this anymore. You can go away. To do 2.754 times 32 plus 71.974 equals 160.102. 160.102. And again, remember with story problems, we have to write our final answer in a sentence. So we can say that a humorous, except for that is the wrong way to spell humorous. Wrong, because it's not humorous as in funny. It's humorous as in the bone. Come on, Mr. Ducharme. Of 32 cm could be a woman with a height of 160.102 centimeters. We're going to do one more example, but notice that this time we're actually going to make a scatter plot on the graphing calculator. Excuse me. So I can show you how that's done. So this is find the following information for this data set on the number of grams of fat and the number of calories in each sandwich served at Dave's Deli. So if you want to try this problem before I do it, go ahead and pause the video. Otherwise, you can keep watching to see what I do. So the first thing I'm going to do is I'm going to input that data into my graphing calculator. I'm going to go Stat, Edit. Oh, I still have old data in there, so I can actually scroll up and clear it. And then scroll up. Oops. I'm trying to use my mouse and it's not letting me. Duh, because it's clicking on the screen. Clear. Great. So now I'm going to enter my fat grams as X. 5, 9, 12, 15, 12, 10, 21, 14. And my calories as X, or Y, 360, 455, 460, 420, 530, 375, lost my train of thought, whoops, 580, 580, and 390, 390. Okay, my data is in. So now I'm going to go to, well actually I'm going to go to my window. So before I go to my window, I want you to take a look at this. All of my X values are between like 5 and 21. So I want to make an X axis that can hit all of them. So I'm going to go to window. My X-min can be 0 because all the numbers are small. And my X-max has to be something like 22. And I'm going to have them count by 2s because it's pretty easy. So if I look at my Y's though, so let's look at my Y's. They're all ranged between 360 and 580. So I'm actually going to make it between 300 and 600. And again, I'm getting these just because I'm looking at my data. I have to count by something that's a little bigger, so I'll count by, it doesn't really matter, 25. So then I have to go to y equals, let's see if I can do this right, y equals, and turn on plot 1. And then graph this. Oh, hey, look. So this is a scatter plot of my data without me actually having to draw it on a piece of paper. It looks like that I'm going to have a positive correlation, but it's not really going to be that strong one. However, I'm going to use my linear regulation to figure all this stuff out. So I'm going to quit this graph because I've now seen enough. I'm going to go to the linear regulation part, which is stat, go over to calculate and down to linear regulation, number 4, hit it, yes, yes, I don't know what this means, I don't know what this means, done. Okay, so as I said, we have a correlation coefficient of 0.68. That's okay, it's not the strongest, but it still means that there's a little bit of a positive correlation. My slope is 11.141, and my y-intercept is 309.76. And I'm just writing this information down. You can't really see it because my calculator's in the way, but I'm just writing this information down so I could compare it for later. It then says graph the line of best fit on the viewing window with your calculator. So I'm going to go back to y equals, and I'm going to type in that equation for y1, 11.141x, that is not x, plus 309.767. I'm going to look at my graph. Okay, so that's the line of best fit the calculator decided. It actually is probably in the middle of all of the data. I think it represents it pretty well. However, as you can see, the reason it doesn't have a super strong linear relationship is there's a couple points that are way far away from it. So, for example, it looks like whatever we decided, that I'm looking right at the one in the middle, but there's still some in the lower part that are all kind of far away from this line. So this is what it would look like all graphed on your calculator. You will have a chance to do this on your test where I say make it on your calculator, look at it, and I might ask you, well, which point does it go through? Well, it goes through this one, and this is my 5,360 point, so at least it goes through 1 point. But I was referring, this point's way far away and might be an issue. These two are kind of far away, but it definitely at least touches this one. So I might ask you, does it touch any of the points? Yeah, it's close to this one, close to 5,360, and it's kind of close to this one, which honestly I don't know what point that is, but I know this is 5,360 because it's the lowest point on the X. So our C says, predict the amount of fat in a sandwich with 500 calories and how accurate you think our prediction is going to be. So I'm going to come down here, and so at 5 calories is actually Y. So I have to do 500 is equal to 11.141x plus 309.767. So the first thing I do is I have to subtract that 309 from 500. So let's quit this. So I can quit. 500 minus 309.767 equals 190.223. So 190.2, was it 223? No, 233. 233 equals 11.141x. I'm going to divide both sides by 11.141 divided by 11.141 to get x is equal to 17.075. Write my final answer as a sentence. So a 500 calorie sandwich could have 17.075 grams of fat. And now I have to decide if this is accurate or not. Well, all I have to compare it to is 15 and 21, but I'll show you a way that maybe we can do this on our calculator. So I'm going to add one more data point. Into my table. So I'm going to go to Stat. I'm actually going to go to Edit, and I'm going to clear these because my line of best fit's already there. Oh. I don't want to do that. Darn it. Okay, fast forward to this. Fast forward through this while I re-enter the data. I was way too fast on deleting this. 12, 10, 21, 14. I want to add one more point. I want to add that 17 17.075 500 point. And I know that this one's going to be on my line because I predicted it. Whoa. And I think it's kind of far away from the rest of the data. So I'm going to say it's a kind of accurate prediction. I would say prediction is, and you can just use the correlation coefficient for this too, is semi-accurate. I would say it's not accurate if it was less than half for a correlation coefficient. Like if our correlation coefficient up here, was like 0.3, then I would say it's not accurate. But at least it's in between halfway and the whole thing, so it is definitely somewhat accurate. Okay, so this has been your first video lesson. The practice is on the bottom of the page. Good luck. Have fun. If you have any questions, please let me know. And this is the end of the 1.7 video lesson.